In this video, we're going to learn the difference between a constant pointer and a pointer to a constant in C. Part of the reason why I want to make this video is that I think it's easy to get confused, because the syntax for both of these concepts looks pretty similar. So if we have a car variable a, and we assign it the character a, we could create what's called a constant pointer to a. We would say car star constant pointer is equal to and a. And here we've made a constant pointer and we've set it to store the memory address of a. So it's going to point to a. We can also have a pointer to a constant, and that's going to look like this. We'd say car const star pointer to const is equal to and a. And this would be a pointer to a constant, and it's going to point to a because again it stores the memory address of a. These things look pretty similar. If you look at the syntax here, it's kind of hard to tell these apart. There's barely a difference. Really, it's just the position of this star here. So what is the difference between these two ideas? So with a constant pointer, we can't change what the pointer is pointing to. We can't change the memory address stored by the pointer. We can change the value of what the pointer is pointing to. So in other words, we could dereference constant pointer, which is pointing to a. And by using this dereference operator, what we're doing is accessing what the pointer is pointing to. In this case, a. And what we'll do is store the character x into a. We could then print out a, and we'll find that a is now storing the character x. So we can do this with a constant pointer. What we can't change is what it's pointing to. So for example, let's say we have another car variable b, and it's equal to b. I can't set constant pointer equal to the memory address of b. I can't change what it's pointing to have it point to b instead, because it's a constant pointer. So if I save this and run it, I'll get an error. It says, cannot assign to variable constant pointer with const qualified type car star const. So we can't change what a constant pointer is pointing to. So with a pointer to a constant, the opposite is going to be true. We're going to be able to change what the pointer is pointing to. We're going to be able to set it to a different memory address, but we're not going to be able to change the value of what it's pointing to. Let's go over an example. So I'll comment out this, and then down here we have our pointer to a constant. So right now it's set to point to a. It's storing the memory address of a. Let's actually print out the dereferenced pointer just to confirm that it is in fact pointing to a. So we'll say %c, and we'll output the dereferenced pointer using the star operator. So we'll save this and run it, and we get that it is pointing to a because a stores the character x right now, and right now we get x when we dereference the pointer. Let's try to set this pointer to point to b. We couldn't do that with a constant pointer. We couldn't change what it was pointing to. But with a pointer to a const, we can. So we can say pointer to const is equal to and b. And we're going to store the memory address of b in this pointer variable. We could then print out the dereferenced pointer after changing what it's pointing to. And we should find, if we save this and run it, that we get the character b, because the pointer is now pointing to the variable b that stores the character b. So again, with a pointer to a constant, we actually can change what it's pointing to. What we can't change is the value of what it's pointing to. So for example, if we dereference the pointer to const pointer, what we're doing in this case is accessing b. And we could try to set it to the character z. If we try to save this and run it, we'll get an error. It says here, read-only variable is not assignable. So we can't change the value of what a pointer to a constant is pointing to. Now, just so you know, we could have also declared a pointer to a constant by flipping around the type and the const keyword. So in other words, if we copied this here and pasted it, we could flip around const and char. And this will also declare a pointer to a constant that's exactly the same as this one here. So if we save this and run it, it's going to work because we have a pointer to a constant. And so far, all we're doing is changing what it's pointing to. But if I uncomment this line where we try to change the value of what it's pointing to, again, we'll get an error because this is just another way of making a pointer to a constant. We can also have a constant pointer to a constant. So for example, we could say const char star const. And this we could say is going to be called constant pointer to constant. And we'll set it to point to A. We'll have it store the memory address of A. Now I can't dereference this pointer because it's a pointer to a constant. So if I say constant pointer to constant is equal to the character Z, if I try to save this and run it, we'll get an error. I also can't change what the pointer is pointing to. So I can't say constant pointer to constant is equal to and B to try to have it point to B. And that's because it's also a constant pointer. So if we save this and run it, again, we get an error. And again, I could flip the keyword const and the type, and it will still be a pointer to a constant. So for example, we could say, let's copy this, paste it, and instead of const char, I'll have char const. And I'll comment this one out. And if I save it and run it, we'll get the exact same errors as before, because doing it this way will also declare a pointer to a constant. So in summary, we can break down the different possibilities like this. We can have a non-constant pointer to a non-constant. In that case, both the pointer and the value that it's pointing to are mutable. They're changeable. We can have a non-constant pointer to a constant. In that case, the pointer is going to be mutable. The value that the pointer is pointing to is going to be immutable. It's a constant. We can't change it. We can also have a constant pointer to a non-constant. In that case, the pointer is going to be immutable in that we can't change it. The value that the pointer is pointing to is going to be changeable. We can have a constant pointer to a constant. In that case, both the pointer and the value of what it's pointing to are both going to be immutable. So hopefully this video has helped you to understand the difference between a constant pointer and a pointer to a constant in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.